Defining condition monitoring locations, CMLs, identifying critical points for equipment health assessment. Overview of CMLs for piping and pressure vessels. Condition monitoring locations, CMLs, play an essential role in the inspection, monitoring, and long-term integrity management of piping systems and pressure vessels. These locations are predetermined physical points where inspectors take measurements such as ultrasonic thickness readings to evaluate the condition of the material and detect any degradation that may be occurring. The definition and strategic placement of CMLs are governed by established international standards to ensure accuracy, reliability, and consistency in monitoring. A well-designed CML program helps engineers track corrosion rates, predict remaining life, and assess the effectiveness of corrosion mitigation strategies. These monitoring points offer critical insights into how the equipment is aging, allowing engineers to make informed decisions regarding repairs, replacements, or adjustments to operating conditions. Proper understanding and implementation of CML placement also enhance safety by ensuring that high-risk deterioration zones are regularly and thoroughly inspected. The creation of such a structured monitoring framework not only supports equipment reliability but also strengthens regulatory compliance and adherence to industry best practices. Through systematic CML placement, inspection programs can become more efficient, targeted, and data-driven, reducing unnecessary inspection effort while improving asset performance and safety. Primary goals of a CML program. The main objectives of developing and implementing condition monitoring locations, CMLs, in inspection programs stem from the need to ensure safe, reliable, and long-lasting mechanical integrity for piping and pressure vessels. One essential goal is to accurately understand and track the deterioration mechanisms that may affect the equipment. By placing CMLs in critical areas, engineers can assess corrosion rates, detect localized damage, and evaluate the overall structural condition of the system. Another key objective is to align inspection practices with international standards such as API 570, API 574, and API 510, ensuring that monitoring activities meet recognized engineering requirements. A well-defined CML strategy also supports risk-based inspection, RBI, initiatives by providing data that helps prioritize high-risk assets, optimize inspection intervals, and control maintenance costs. Furthermore, the CML program aims to enhance safety by detecting potential failure mechanisms before they pose operational or environmental hazards. Ultimately, the program supports proactive asset management, enabling engineers and inspectors to make data-driven decisions that improve equipment reliability and operational continuity. Definition and purpose of CMLs. Condition monitoring locations, CMLs, are predetermined, repeatable inspection points on piping systems and pressure vessels where measurements, such as wall thickness readings, are taken over time to evaluate the progress of degradation. CMLs allow engineers and inspectors to monitor corrosion, erosion, fatigue, and other damage mechanisms. The primary purpose of a CML is to provide a consistent and reliable reference point for evaluating material loss trends and calculating corrosion rates, which subsequently inform remaining life assessments and maintenance planning. These monitoring locations are also essential for validating the effectiveness of corrosion control methods such as inhibitors, coatings, or material upgrades. Establishing well-defined CMLs ensures that inspections are systematic, targeted, and meaningful, allowing for reliable comparisons between historical and current measurements. The structured use of CMLs enhances asset integrity programs by providing accurate data needed for engineering evaluations, regulatory compliance, and safety assurance. Ultimately, CMLs serve as the backbone of predictive maintenance strategies, allowing operators to identify potential failures before they escalate into major incidents. International codes governing CML selection. Several internationally recognized standards provide guidance on defining and selecting condition monitoring locations, CMLs, for piping and pressure vessels. API 570 outlines the in-service inspection requirements for piping systems and emphasizes the significance of strategically placing CMLs at locations prone to corrosion or degradation. API 574 complements this by offering detailed guidance on typical corrosion zones in piping, including elbows, dead legs, injection points, low-flow areas, and insulated sections. Meanwhile, API 510 governs the inspection of pressure vessels, specifying the need for representative CMLs on vessel shells, heads, and nozzles. Additionally, API 580 and API 581 provide methodologies for risk-based inspection, RBI, allowing operators to optimize the number and placement of CMLs based on risk levels and historical performance. ASME B 31.3, though primarily a construction code, influences CML considerations by detailing requirements for welded joints, material selection, and fabrication details that can affect degradation. API RP 571 provides essential knowledge on damage mechanisms, serving as a reference for identifying areas where CML placement is most critical. Together, these standards form a comprehensive framework for developing effective and compliant CML programs. Engineering considerations for effective CML placement. The principles of condition monitoring location, CML, selection revolve around engineering judgment, historical inspection data, and expected damage mechanisms. One of the core considerations is identifying zones where deterioration is most likely to occur. This includes areas exposed to turbulent flow, temperature fluctuations, corrosive fluids, or mechanical stresses. Another key principle involves positioning CMLs where readings can be reliably repeated during future inspections, ensuring consistent and accurate trend analysis. Accessibility also plays a crucial role, as CMLs must be placed in positions where inspectors can safely and effectively perform measurements. Additionally, environmental factors such as insulation, weather exposure, and potential for corrosion under insulation, CUI, must be factored in to ensure comprehensive monitoring coverage. Engineers must also consider the equipment's operating history and any observed degradation patterns when determining CML placement. By adhering to these principles, organizations can design CML programs that provide meaningful insights, support proactive maintenance, and enhance the safety and reliability of assets.